Next type of graph is weighted graph. A graph G is said to be weighted graph if each edge of the graph is assigned with some positive real number called as weight. Means this type of graph is used for finding the shortest distance. Means each and every edge having certain weight, which having some positive real number value. So in this example, you can see that the edge from 5 to 6 vertex having a weight 5, then 5 to 4 having a weight 10, likewise. So each and every edge having certain weight. Next type of graph is simple graph. So graph is called as a simple graph if it does not contain any self loop or parallel edges. Then it is called as a simple graph. So in definition you can see that a graph is said to be a simple graph if it does not contain neither the self loop nor the parallel edges. Next type of graph is finite and infinite graph. A graph with finite number of edges and vertices, these are called as a finite graph, and a graph with infinite number of edges and vertices is called as an infinite graph. So in case of finite graph, whatever graphs we see up till now, all these are the finite graph which having a finite number of vertices and finite number of edges in the edge set. Now if you see this example, these are the examples of infinite graph where number of vertices and number of edges in the graphs are infinite, or we can say it is uncountable. Next type of graph is null graph. If the edge set of any graph G with n vertices is an empty set, then the graph is called as a null graph. Means graph having the vertices set with the vertices and edge set is empty, so that type of graph is called as a null graph. So you can see here the example of null graph which contain only the vertices. Then next type of graph is complete graph. A graph G is called a complete graph if every vertex in G is connected with every other vertex. So that is, degree of each vertex should be n minus 1. So in case of complete graph, each and every vertex is connected with other graph with the edge. Then it is called as a complete graph. And because of that, degree of each vertex will be n minus 1. So graph with n number of vertices is denoted by kn. So total number of edges can be calculated by using the formula n into n minus 1 upon 2. It gives the total number of edges from the complete graph. Now we'll see some example of a complete graph. This is the K1 graph where number of vertices are 1. K2 graph, number of vertices are 2. So degree of each vertex is n minus 1, that is 2 minus 1, that is 1. Then complete graph with 3 vertices. So n value is 3, it's also called K3 graph. So degree of each vertex will be n minus 1, that is 2. This is the complete graph with the 4 vertices called as K4, and this is the complete graph with the 5 vertices, that is K5. Now next type of graph is regular graph. A graph is called as a regular graph if each vertex having the same type of each vertex having the same degree, then it is called as a regular graph. So if degree of all the vertex of a graph G is same, say D, then it is called as a regular graph. So you can see there some example of regular graph. Regular graph with 0 regular graph means there is only one vertex, so degree of vertex is 0. Regular graph with 2 vertices, it is called as a 1 regular, as every vertex having a degree 1. This is 2 regular graph. All these are the 2 regular graph, as degree of each vertex is 2. So here we can make a statement: complete graph is always the regular graph, while every regular graph may not be the complete graph. So every complete graph Kn is a regular graph of degree n minus 1, but vice versa is not true. Now next type of graph is multigraph. A multigraph is a graph having self loop and parallel edges are called as a multigraph or multiple graph. Means if the graph contains self loop and parallel edges, or only parallel edges or only self loop, then also it is called as a multigraph. These are the some example of multigraph. So you can see in this first graph it contains a parallel edges also and self loop also, so it is a multigraph. Here we can see it contains the parallel edges, so it is a multigraph or multiple graph. Next type of graph is bipartite graph. So bipartite graph is a graph G with vertices V and edges E are called as a bipartite graph if its vertex set can be partitioned into two sets such that following condition should be satisfied, that is V1 union V2 is equal to V, V1 intersection V2 is equal to phi, and third condition, each edge should join from V1 to V2. Then that graph is called as a bipartite graph. Means here we are dividing the vertex set of the given graph into two sets, that is V1 and V2. After dividing this, we will check V1 union V2 should be equal to total number of vertices or vertex set of V of original graph, and V1 intersection V2 should be phi. Means there should not be any common edge between these two vertex set V1 and V2. And third condition is that each edge should join from V1 to V2. Means edge will be exist in the graph only if first vertex is from V1 and second vertex is from V2. So here you can see that this graph vertices are divided into two sets. One set is shown by the blue line, blue vertices, and V2 is by the red vertex, and V1 there is a edge exists between the in the graph which is always from the V1 to V2. Next term is bipartite graph, but it is complete bipartite graph. A bipartite graph is called as a complete bipartite graph if each vertex of V1 is joined to every vertex of V2 by an unique edge. Means each vertex from vertex set V1 is connected with each and every vertex of vertex set V2. In that case, it is called as a complete bipartite graph. So it is denoted by KMN, where M is nothing but number of vertices from vertex set V1 and N is nothing but number of vertex from vertex set V2. So total number of edges in the given complete bipartite graph is always is equal to M into N. So regular graph, if M is equal to N, in that case it is a complete bipartite graph. So you can see that some example of complete bipartite graph. So vertex set V1 is contain two vertex, that is A, B, and vertex set V2 contain three vertices C, D and E. So there is a edge between each and every vertex, means every vertex of vertex set V1 is connected with all other vertices from the vertex set V2 by the edge. That's why it is called as a complete bipartite graph. And total number of edges we see in formula, that is M into N. In this case M value is 2 and N value is 3. So 2 into 3, total number of edges will be 6. So you can check here, these are the 6 edges. And this is the complete bipartite graph. In this case vertex set V1 contain 3 vertices and vertex set V2 contain 4 vertices. So total number of edges will be 3 into 4, that is 12. And you can see in this 12 edges are there. Now next type of graph is acyclic graph. A graph without cycle is called as an acyclic graph. Means there is no any cycle exist in the graph. That's why that graph is called as a cyclic graph. You can see the example here. There is no cycle is exist. This is the directed graph. So in directed graph, direction is important. So all arrows should be in one direction in the loop. Then only it is called as a loop. Next type of graph is trivial graph. A graph with single vertex and no edges are called as a trivial graph. There is only one vertex, then it is called as a trivial graph.